In this lesson, we'll be discussing how we can relate the specific heat at constant pressure, specific heat at constant volume, as well as there's a new term called the specific heat ratio. So let's take again, we're going to be looking at an ideal gas. So for an ideal gas, well actually for any situation, we say that the enthalpy is going to be equal to internal energy plus the pressure times specific volume, for the specific enthalpy, excuse me. We also know for an ideal gas, the pressure times specific volume is going to equal the universal gas constant divided by the molecular mass, or molecular weight, times the temperature. We can see we have those pressure times specific volume terms, which we can make a substitution, and so then we can get enthalpy is equal to internal energy plus universal gas constant divided by the molecular weight times temperature. We can then differentiate this equation with respect to temperature, so everything will be in terms of ddt. If we do that, we get the differential of enthalpy with respect to temperature is equal to the differential of internal energy with respect to temperature plus the universal gas constant over the molecular weight of the times the differential temperature with respect to differential temperature. Well, differential temperature over differential temperature is just going to equal 1. So if we substitute now what we know about specific heats, we know that the differential with respect to enthalpy over temperature is the same as the specific heat at constant pressure, and we know that the differential with respect to internal energy over temperature, excuse me, the differential of internal energy with respect to temperature is the specific heat at constant volume plus that universal gas constant molecular weight. That's equation 1.58. So this is how those two relate, the specific heat at constant volume and pressure. We also have a term called the specific heat ratio, another way that we can relate the two. And for the specific heat ratio, we say that for an ideal gas, that specific heat ratio, which we use the letter K for, is going to equal the specific heat at constant pressure divided by the specific heat at constant volume. Now there is another way we could define this. So again, let's substitute in for the specific heat at constant pressure how we just defined it in the last page of specific heat at constant pressure equals specific heat at constant volume plus universal gas constant over the molecular weight. So we take that equation 1.58 and we substitute into the numerator for how we define K. And what you end up with is specific heat at constant volume plus the universal gas constant over molecular weight divided by specific heat at constant volume. Well, the first two terms cancel out and become 1. And so what we get is specific heat ratio can be also defined as 1 plus universal gas constant over molecular weight times specific volume, or specific heat at constant volume. So you can define specific heat ratio without ever using the specific heat at constant pressure.